In this problem, it says you have a 24.06 gram sample of pure sodium is prepared for an experiment. How many milliliters of sodium is this? Then it gives me the density. So if I review like what I'm given, I know that I have a 24.06 grams. So that's my mass because the unit of grams is for mass. And then as I continue reading my problem, the question is how many milliliters? So milliliters is the unit for volume. So I don't know the volume. That is what I'm going to be trying to calculate in this problem. And then the other piece of information that I'm given, I know the density. So for me, once they give me the density, that is a clue that I am going to use the density equation to solve this problem. So I remember that density is equal to the mass divided by the volume. So looking at what they've given me, I know the density and I know the mass. So I am going to calculate the volume. Now, the first way I'm going to solve this is algebraically, so using math. And oftentimes, I might approach it slightly different than you do, just depending on how we learned to rearrange equations. So I always encourage you to pause and try to rearrange something before you watch me do it. Okay, so you might try that first. Now, there's two thoughts here that I have. One is I can rearrange the equation before I put any numbers in. So I'm going to do that in the lower left corner just to show you. And then the second way I'll do it is I'll plug the numbers in. I'm showing you both ways, not that you have to know how to do it both ways, but I have students that like to do it both ways. So let me just show you. All right, so down here I'm going to show you. So here's the original equation. I'm writing in the lower left corner. So I want to solve for volume. Now volume is currently in the denominator. So I need to get it to where it's in the numerator on the top. Otherwise I'll be solving for 1 over volume. So I'm going to, since it's on the denominator here, I'm going to cross multiply it to the other side. So it would be volume times density now equals mass. Okay, so I'm going to multiply it over to the other side. And then now I need to get volume by itself. So I'm going to divide both sides by density. So then it says volume equals mass over density. So I could right there now plug in for the mass, which I know, and the density, which I know, and get my answer. So that would be one way you could rearrange the equation first. The second approach you could take is to plug in the numbers and then rearrange the equation. So I know the density is 0.97 grams per milliliter. And I know the mass is 24.06 grams, and I don't know the volume. So I'm just going to write V as my unknown because it's volume. If you're more used to writing X, you could do that as well. So now the process is going to be the same. I can't solve for volume right now because it is in the denominator. So I'm going to multiply the V to the other side. So then I would have V times 0.97 grams per milliliter equals 24.06 grams. Then I need to get volume to the other, I need to get volume by itself. Here's volume. So I'm going to divide the density over to the other side. So I'm then going to have volume equals 24.06 grams divided by 0.97 grams per milliliter. So then my grams cancel, and I have units of milliliters, which makes sense because I'm solving for volume. So I'm going to, in my calculator, 24.06 divided by 0.97. And I get the number 24.804, and it keeps going. So now to report my answer in correct significant figures, I look back. The rules in multiplication and division are to look at the numbers that you're given and round to the number of significant figures of the number that has the fewest. I didn't say that very clearly, but let me do it. So I'm going to look back at these two numbers. That one, 24.06, has 4 significant figures in it. And then the other value I was given is 0.97, which has 2 significant figures. And so the rule in multiplication and division is that you look at the numbers that you're given, that were measured, that they gave to you, and you find the one that has the least, and that's how many significant figures you want to round your answer to. So in this example, I have 2 significant figures. And so I'm going to round my answer to 2 significant figures. So coming back here to the 0.80, I'm going to, let's see, I want only the 2 and the 4. So the first number I'm dropping off is an 8. So 24.8 would round to 25 milliliters. And so the answer that I would report is 25 milliliters right there. Now, I'm going to take this opportunity to show you one more way you could solve this, and it's using density as a conversion factor. And it doesn't require you to rearrange like I did on this slide. So let me just, whoops, I didn't change my marker. Okay. So this is a possibility if you don't like rearranging algebraically. If you're given density, you can use it as a conversion factor. So let me just go back to the previous slide. Let's see, the mass is 24.06 and the density is 0.97. Okay. So, oops. Now, density means that you have this many grams, 0.97 grams in 1 milliliter. Like when we write it and when we say 0.97 grams per milliliter, but what it is representing is the number of grams in 1 milliliter. And so if you look at this right here, right here, that looks like a conversion factor, right? Because we have 2 things, one on top of the other. And so if you can always use density as a conversion factor, because whatever the density is, it's that many grams in 1 milliliter. So then what you would do is you start with whatever you're given, not the density, because we never start a problem with a conversion factor. We always start with something that we're given. So in this case, we're given the mass, and then we're going to treat the density like a conversion factor. So remember, in conversions, if grams is here, then I would need grams to be in the bottom. So then I take the 0.97 grams, and then I put the 1 milliliter at the top. And so what happens is I cancel my grams, and I have milliliters remaining. And so my answer, what I do on my calculator is I take 24.06 times the 1 divided by 0.97, which gives me the 24.80, which rounds to 25. So see, I didn't have to rearrange, and I still get mass divided by density, which look, when we rearranged down here or down here to solve for volume, we had mass divided by density. So you are able to use density as a conversion factor if you find that that makes sense to you. You are also always able to rearrange the equation algebraically like I did on the first page. I just thought I would mention this to you in case it makes sense and maybe makes something easier for you. So like always, if you have any questions, you need further clarification, please feel free to reach out to me.